Welcome back, students. We're going to continue our discussion of Earth cycles, and for this video lecture, we're going to look at the big picture. We're going to look at geological time. We're going to step back, take the real big view. Let's begin by recalling that 72% of the surface of planet Earth is covered with water, and water freezes at 0 degrees and boils at 100 degrees centigrade. The average global temperature is 14 degrees, so most of the water on planet Earth is in the liquid phase, in the oceans primarily. But there's a range of temperatures from the poles to the equator, as shown in this graphic. In the poles, the average temperature can be minus 20 degrees or so, the South Pole being colder than the North Pole. And in regions around the equator, we can have average annual temperatures that are near or exceed 30 degrees centigrade. What this means, of course, is that water is in its liquid phase in most regions of the world, but it exists as ice in the polar caps, the North Pole and the South Pole region. About 1.7% of the water on planet Earth is found in this frozen ice state in the ice caps and in snow. A little later in this video lecture, we're going to talk about ice ages, and in periods of ice ages, as much as 5% of the water on planet Earth is in the frozen ice state. So it can go from the current level of about 1.7% of water being in the ice state to as high as 5%. And that has profound consequences due to the fact of the different densities of ice and water, leading to a reduction in sea level when water freezes to ice, and also when more of the water is in the form of snow, it doesn't seep into the groundwater and through the rivers and streams back to the sea and to the oceans. Now let's talk about these ice ages. It is one of the large and very important cyclical events on planet Earth. We'll see in a graphic in a second that these periods can be very long periods. And when an ice age occurs, there is a drop in the average global temperature. Up to 5% of the water freezes, as we said, resulting in reduction in sea level. There can be advancing glaciers. The last advancing glacier was about 20,000 years ago, and it moved as far south as Illinois in the North American continent. And of course, land bridges can form between like Asia and North America. Glaciers can carry rocks and soil, which can alter both the landscape and the fertility of the soil. Over the past million years, the Earth has had an ice age period of about 100,000 years, and we'll see that in a little bit more detail in the next slide. This slide shows evidence of the average temperature of Earth over the past 5 million years. Now we'll talk later on about how there's evidence that the actual age of the Earth is about 4.5 billion years, so much older than is shown in this graphic. But we have data from sediment cores by comparing the ratio of isotopes of oxygen. It gets very technical, but there's a method for determining the average global temperature extending back through time from these core samples. And as you can see, there's a dramatic oscillations in this temperature. There's an overall cooling of planet Earth over this period of 5 million years, but tremendous oscillations. The frequency of these oscillations had been about, on a cycle of about 40 kiloyears, 40,000 year cycle, up until the last million years, in which it's actually slowed down.
These temperature oscillations now occur with a period of approximately 100,000 years.
I've blown up the last 500,000 years, 450,000 years to be exact, shown in the drawing below, which shows the average global temperature in two different regions, two different research stations, and in the very bottom graph is the ice volume over this period of time. So ice ages are those periods in which the average temperature is much below, and you can see that that average temperature compared to the ambient temperature today of about 14 degrees centigrade, the average temperature in these cold periods has dropped to as much as -6 to -7 degrees.
below the current global average of 14 degrees centigrade, which would be
40 to 45 degrees Fahrenheit for comparison as the average. And you can see that in these low temperature ice age periods, there has been a higher level of ice volume. Now, we've often talked about how, well, man has lived through the ice ages. Well, yes, that's true. The earliest evidence of human-like ancestors dates back to about 200,000 years. So man did live through at least one ice age and then a second ice age. But keep in mind that recorded history is only the last 5,000 years. So on this plot, recorded history is only about the size of this red circle, and over which time the temperature has been fairly constant up until recently, which we'll talk about later when we talk about global warming. So even though humans or our human-like ancestors have survived the ice ages, that's not modern humans. We haven't lived through the ice ages. Now the question is, what causes these oscillations in temperature leading to prolonged periods of cold called ice ages? Well, before getting to that, let's talk about what causes the seasons. You probably know that the seasons, summer, fall, winter, spring, are caused by the tilt of the Earth's rotational axis, such that in the summer, the tilt of the rotational axis of the Earth is such that the northern hemisphere is closer to the sun, leading to summer. That's called the summer solstice. And then in the winter, the tilt is just the opposite, so that the southern hemisphere is closer to the sun and the northern hemisphere is further away, leading to winter. So we have the summer solstice and the winter solstice, all due to the tilt of the rotational axis of the Earth. You may have also heard of the term equinoxes. Equinoxes are those two other points during the calendar year in which the amount of sunlight is equal, shining on the north and the southern hemisphere. Another explanation is that the equinoxes are the time at which the sun is directly above the equator, 2 points of time in a year which is directly above the equator. So first we wanted to talk about the reasons for seasons on planet Earth before then talking about possible explanations for these long-term oscillations in the temperature of the Earth. A Serbian geophysicist named Milutin Milankovic first proposed explanations for the ice ages or for these periodic changes in the temperature, global temperature of Earth. One of these explanations he proposed is what is called the precession of the equinoxes. Pretty fancy term, precession of the equinoxes. Now what does this mean? If the Earth is a spinning top, the rotational axis of that spinning top, we are told, points towards the North Star, Polaris, which is the brightest star in the Little Dipper, also called the Ursa Minor constellation. So that rotational axis points towards the North Star. But the phenomena of precession of the equinoxes means that that rotational axis is actually changing with time, and at some point in time, maybe 10,000 years or so from now, the rotational axis will no longer point towards Polaris, but will point towards other stars. The simulation shown to the right illustrates this. Okay, so you see that now the rotational axis is pointing towards Polaris, and that over time it may actually point towards another star, Vega, as being the North Star. So that's one explanation proposed by Milankovic. There's evidence that this precession of the equinoxes occurs with a period of 23,000 years, which can provide at least a partial explanation for the 100,000 year period of temperature changes on planet Earth. A second explanation has to do with the tilt of the rotational axis itself. That tilt of the rotational axis can flip between 24.5 degrees to 21.5 degrees. That's like the top itself, instead of being rotating a certain angle, it suddenly changes. And this appears to occur with a period of about 41,000 years. Other hypotheses for explaining the periodic changes in temperature are the actual changes in the orbit of the Earth around the Sun, from being more elliptical to more circular. Additionally, there may be changes in solar output over time. And also the movement of plate tectonics may contribute to the changes in temperature in a periodic manner over time. So these are potential explanations for the changes in temperature with respect to time. It's estimated there may be another glacial advance or ice age coming in about 10,000 years. But again, recall that human history is only about 5,000 years old, so you shouldn't have to worry too much. And global warming, which we'll talk about a little later, is advancing much more rapidly than the projections for the coming ice age. Okay, we'll pause again, have a quiz on this material, and then we'll talk about the weather. See you shortly.